In this video we shall finish discussing normal forms. Just a quick reminder, refer for these normal forms to the first video, for these normal forms to the second video, and now we shall discuss these normal forms beginning with the fifth one. The fifth normal form states that a real var is in the fifth normal form if it satisfies the fourth normal form, and with respect to a set of functional multivalued and joint dependencies, if for every non-trivial joint dependency like this in that set, every part of that joint dependency is a superkey of the real var. In other words, we have to know each candidate key and each joint dependency of the relation, and we have to make sure that each projection for each joint dependency contains a candidate key that is a part of superkey, of course. Let's review this in details. This example should be familiar to you from one of the previous videos when we were discussing dependencies. So, joint dependency here is the next. We have the following situation, that none of these projections contains a potential key, and we have a specific rule from the subject matter. If a tutor delivers some subject S, and some faculty F has that subject S, and this tutor works on this faculty, he has to deliver the subject on this faculty. How does it look like with data? There is mathematics on exact science faculty, the record number 1. Petrov works on exact science faculty, that's the record number 5. Petrov delivers mathematics, that's the record number 3. And following from that subject matter rule, Petrov has to deliver mathematics on exact sciences faculty, and that's where record number 6 comes from. So such a strange situation, and yes, this is the violation due to this situation. How to deal with the situation? There are two ways, and the first is scientific one. We may split this relation into three such relations. We may now make any relationships here as long as adding any foreign key will bring us to the initial relation. So this is scientifically good, but from the point of view of the engineering, this is not good. And let's see how the engineering works here. With the fourth normal form, we had to have 5 relations. Here we have to have 6 relations. We have to have relations for tutors, subjects, faculty, and interconnections between all of those relations. And with this situation, there are no violation of any normal form, nor the fifth, neither any previous normal form. So that's how easy we may achieve the desired result. So only split initial relation into several ones, 6 in our case, and make relationships between that relations. And that's all. Here is a short conclusion. The fifth normal form, like the fourth and several previous ones, does not protect you from local mistakes. Like, for instance, you may write some tutor name with typo or something like that. But it keeps you from violating global rules, like what exam is on what faculty, and so on and so on and so on. And one of the most obvious evidence of the fifth normal form violation is that a relation has a group of 3 or more attributes, and each and every attribute inside such group is dependent on each other. This is how it may look like. We have several attributes like A, B, C, for instance, and the A depends on B and C, the B depends on A, the C depends on B, the C depends on A, and so on. So just rewind the video a couple of minutes ago and see that relation with tutors, subjects, and faculties. This is the situation. But there is the bright side. Most relations that satisfy fourth normal form, and as we remember, Boy's code normal form, and the third normal form, are also in the fifth normal form. So once you have the third normal form, more likely that you have the Boyce Codd normal form and the fourth normal form and the fifth normal form, because we have to have specific subject matter rules to violate these or these or these normal forms. And such subject matter rules are extremely rare in real life. Extremely. So that's good. The domain key normal form definition is rather simple. A real-var is in domain key normal form if all constraints and dependencies that should hold on the relation can be enforced simply by enforcing the domain constraints and key constraints on the relation. In other words, any rules applicable to the relation are originated from its attributes properties, and there are no other hidden rules. What hidden rules there may be? Just remember our previous example about tutors, subjects and faculties. And you remember that strange rule that if a tutor does something here with that subject and that subject is at some faculty and that tutor is at that faculty, he should deliver that subject at that faculty, and so on and so on and so on. These are the hidden rules. So if there are no such hidden rules and we only use constraints from keys and from domains, there maybe everything's okay with domain key normal form. But let's review the example of violation and how to deal with it. Here is the violation. There is a rule in the subject matter that each employee may have any number of roles but one position only. So we have position, position, position and role, 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 role here. With roles everything's okay, but with positions, here it is and here it is, we see that some Ivanov has two positions, but that violates our rule. That's the problem. Yes, that's the problem. So we have to deal with it the following way. We have to split the initial relation into the next two. Here we have employee name as our primary key, so we cannot add another Ivanov here. The DBMS will prohibit that situation. So now each and every employee may have one position only. But here we have compound primary key, and so each employee may have as many roles as we want. And here's the conclusion about domain key normal form. Alas, some relations may violate domain key normal form due to extremely complicated subject matter rules. Those rules are not easy to detect, but there may be such situations. One of the most obvious evidence of domain key normal form violation is that the subject matter has such rules that enforce you to use some complicated constraints beyond relation theory. For instance, once again we are speaking about our employees and their positions or roles. We may use some trigger here or something like that that will somehow magically, in quotation marks, detect if a value here is either position or role and prohibit inserting several positions for one employee but allowing inserting several roles. But that is such a strange technical decision beyond relation theory. If you have to do it, maybe your relation violates domain key normal form. And there is a fact that normalization to domain key normal form usually requires not a decomposition, but a complete rework of initial relations. That's the example we've already seen with this relation a couple of minutes ago. That's for real, not a decomposition, but a rework of that initial relation into something new. And here is the final normal form, the sixth one. A real var is in sixth normal form if it can't be non-loss decomposed at all, other than trivially. It asks if and only if the only joint dependencies to which it's subject are trivial ones. In other words, while decomposing a relation into projections, at least one of such projections will be equivalent to the initial relation we are decomposing. Here how it looks like with data, the violation example. First of all, we have to emphasize that sixth normal form usually deals with some temporal data. It acts with some dates or time periods and so on. And we see in this education path that a student may change the group staying at the same faculty, or he may change the faculty staying at the same group. So there may be some overlapping of that periods, and what can we do with the situation? We may split it, or in other words, decompose vertically in two new relations. Here they are. This is our initial relation, then we've split it here and we got two new relations. And we cannot decompose these two relations any further or split them somehow. So this is the final situation. But if, for instance, we have not a real date here, but such placeholder as now, we may split that not vertically but horizontally. Please refer to the video about dependencies. But here we do not have that now, and that's the final state, the final situation. We cannot decompose such relations any further. Here's the conclusion for the sixth normal form. The sixth normal form is actual for chronological relations. For any other relations, the fifth normal form is the ultimate one. One of the most obvious evidence of the sixth normal form violation is that the relation has several independent attributes that are related to each other through the same chronological attribute. This is where the vertical decomposition comes into stage. And the sixth normal form is the ultimate normal form. No further normalization is possible for any relation. So, no more normal forms. To memorize all the material better, please pause the video for a couple of seconds and once again review the huge list of normal forms. And the final idea here that we shall not discuss, that's just a small cheat sheet here for you. It's about normal forms and situations with that normal forms, so you may easily print this picture and read through it, refer to it once you need to remember something about any normal form you like. And yes, that's all about normal forms.